So I'm just going to draw a point anywhere in this flow net. And I'll just call this point right there. Okay? So let's do a couple of things. Maybe first of all, let's compute the total head from this point. Let's do that first. Okay? Very good. Okay, any questions? Just kidding. You guys see how I did that?
What was the answer? I didn't hear it.
It was more like 29.3 or 29.3, whatever. 32 maybe, if you're estimating it. How did you get that? Well, okay, so what are these lines here?
It's the head.
Hydraulic gradient.
Yeah, so head drops, equipotential lines, or total head contours. There are different ways you can refer to them. I think nobody calls them total head contours except me. But I like that because that's what they are. They're contour lines for total head. And so in this little solution here, with this particular flow net, I made this problem very easy. But the first thing that I did was I labeled all of my contour lines. Okay, well that's pretty easy. And so if that's the case, and my point is halfway, or a little more than halfway between 29.5 and 29, so what's my total head?
Somewhere between there.
About 29.3-ish. But what if I didn't have these labels here and I just had lines? What could I do?
You calculate.
Okay, you take the total change in head and divide it by the amount of squares you have.
Okay.
Equipotential.
Well, not the amount of squares, but the amount of head drops.
Yeah, that's what I didn't know how to say it.
Okay. And that'll give me how many head, or how much head I lose per drop. But that still doesn't allow me to fill in these numbers unless I know the starting number and the ending number. Those are my boundary conditions. How do I get those? What do I need?
Is it just the water level, the Newby's equation?
Water level relative to what?
You need
The
it.
datum. Okay, don't forget the datum. If these things aren't labeled, but you want them to be, the first thing you need to establish is the datum. So if I draw my datum right here at 0, which is a common thing to do, what's the water level up here from my datum? It's about 32, which means that anywhere in this pool of water, what's my head?
32.
32. Even right on the ground surface? Yeah, 32. So that ground surface, it becomes a head line, an equipotential line equal to 32.
I'm not sure why, but for some reason it's not clear in my mind as to why it's 32 anywhere in the water.
Well, that again relates to, let's see if this one's any better. That relates to this equation. Head equals where this is
Pressure head.
pressure head.
So the water level represents the total head, and if we move somewhere different in the water, then maybe our elevation head will decrease, but our pressure head will increase, and our total head will be the same.
That's right. So if I go deeper in the water, what happens? I'm moving towards the datum. So what happens to my elevation head?
Decreases.
It decreases. But as I go deeper in the water, what's happening to my pressure?
Increases.
It increases. And it increases in such a way that
H remains constant.
that remains constant. Make sense? It's not until we start moving down through a porous material, that energy becomes loss, head loss, and that starts decreasing. Make sense? Okay, Ryan, did you have a question too?
Yeah, is there any reason you can't draw your datum? I don't know if that's a weir or what, but like on the bottom of the weir? Cause it's just, I
This?
mean, yeah.
No,
'Cause it's
you
just
can
the-
draw it.
It's just the difference between those two, right?
That's right. If you want to draw your datum 10 feet above in the sky, I don't care. But everything has to be relative to your datum. And when you compute your pressures and everything, you'll find that they'll all come out and will work okay. Okay? So if I ask you to compute a total head somewhere, I'm probably going to tell you compute it relative to some datum. That way, otherwise everyone will give me a different number. Because total head is relative to what the datum is. Okay? So I would get my total head at my entry, get my total head at my exit, and then if I knew how much head loss I had per drop, all of a sudden I can put labels on all my content. Right? Right?
Sorry, can you give me the overall purpose of why we want this, what this gives us and what it's showing us? Like the overall reason why we want to do this? Does that make sense? Like, what I'm wondering. Why is this?
It
important?
allows us to estimate flows, velocities, or pressures in hydraulic structures, earth and hydraulic structures in the ground. That's the technical answer. But I think as we compute some of these numbers, you'll see maybe why we like flow nets, why we use them. So, okay, so we got that. That was equal to 29.3 or so. Okay, number 2, let's compute the pressure at A. So I want to know what the pore pressure is right here. The pressure in the voids. Then your phase different. Okay. So, how do I solve for pressure? We're computing pressure in the voids, Jeffrey. And I was picking on you a little bit because I said voids, but you didn't give me a reaction.
So you just go back to your equation, right?
Okay.
And you can do that pressure head plus elevation.
Is equals so pressure head plus elevation head. So do I know that?
Yeah.
Yeah. From my contour lines. I don't know that. Do I know that?
Yeah.
Yes. Do I know this?
Yes.
What's this?
It just reads
Wherever
straight.
it's at.
18-ish.
Yeah.
This is just the, what is it? The elevation head. How do I get it?
From the datum.
From the, it's the vertical distance from my point to the datum. If I'm above the datum, it's positive. If I'm below the datum, it's negative. Makes sense? So this would be, oh man, I totally just did Mr. Bean right there. So about 16.
Hey, Elise, can I
You
put
guys
this
ever
on your
watch
desk
that when he's
so you can get a better
got pictures
peripheral?
in the wall and he's like, got his pencils, and he's
Just
like
put this.
measuring things.
Stick it on your.
I laughed so hard every time I see that. All right. So this would be 29.3 feet equals pressure at A divided by 62.4 pounds per cubic foot plus, what did I say? 16 feet. So subtract 16 from this, multiply by 62.4. Anyone have a calculator? Want to punch that out for me?
Here, let me see if I can find it better.
So this minus 16 times 60. What is it?
829.
8.
829.
Oh, 829.